Let's talk a little bit about intake ports and volume as far as area of the port. I'm doing area of the port in millimeters, and my theory is that the port should be the same size all the way through. So I've got a 3120 and a 660 to compare the differences in these ports. So I wrote down some numbers here and some notes. So the area of the carburetor opening, not considering the throttle shaft, shutter, choke shaft, all that kind of stuff, just measuring the hole. We don't have to overcomplicate this, but get a ballpark idea where we should be at. Area of the hole on a 3120 is 572 millimeters. The block is the same size hole, and the other end of the block, to match the port to the cylinder, was slightly smaller, a less area. If you look at a 66, the bore of the carburetor is 346 millimeters. The boot's the same all the way through, one end to the other. And then the port here is 2 millimeters larger. So right off the bat, when you put the boot on there, you've got a eddy in there. This is larger than the boot, and that creates a problem. That area becomes 452. So then I take a block, my cylinder block, and I stick it down in there. And I put these marks on the side of the port, top and bottom. Measure my surface area. I'm not considering my radius. I'm gonna lose a little area with the radius, maybe 4 to 6 millimeters. I'm not that fussy to get it perfect. In reality, there is no perfect. So let's not overcomplicate it. Let's just, if you want to add 6 millimeters onto the port size, that's fine. But we're getting closer, right? So the port size, by measuring it square, is only 462. We're over 110 millimeters of, square millimeters of area shy. If you look at a 660, the carburetor's 346. The area at the boot on the cylinder is 452, and the area at the cylinder at the piston is 486. So it gets quite a lot bigger. We're looking at 140 square millimeters bigger, where the 3120 gets smaller. And I think that they should be the same size all the way through. I generally epoxy the roofs down on these 660s and stuff to make that port smaller, and all the way around it to make it fit the boot, so I don't have that eddy in there, That's just disruption of flow. The 660 port becomes very lazy, and the 3120 becomes restrictive. And so we talk about RPM, and there's everybody seems to say, oh geez, you want more RPM, you got to raise the exhaust. The exhaust ain't where you get your RPM, guys. Well, to a point. I mean, if your exhaust port's only 120 degrees in duration, then yeah, that's restrictive. But, if you've got a reasonable exhaust port duration, anything reasonable, you're not going to gain any RPM or usable RPM by raising the exhaust. Raising the exhaust is going to decrease your compression. It's going to decrease the duration that the charge or whatever is pushing down on your piston. That time is shortened so it doesn't push as far. And all of those, that's decreasing your torque. So you can trade some unusable RPM and take some torque away, and by raising the exhaust. Both those are things that I don't have any interest in doing. And it depends on your exhaust duration, but that's somewhere of where we are. The place we get our RPM is all in the intake. And just think about it. How much air the engine gets controls how fast it's going to run, right? Throttle shut, it's closed. Throttle open, we get a little more. Wide open, we get our full throttle. It's how much air we're feeding that engine controls the RPM. It's that way all the way through to your port timing. All right? The size of the port and port timing. Now, there's a lot of different ways to alter your port timing. You can lower it, you can raise it, you can put some epoxy in there, you can change your port timing. You can also cut your piston skirt. If you want more duration, you can cut off your piston skirt intake side and give yourself more duration. On a race saw, those ideas are all fine. It's a customized piston. It's a race saw. It's longevity is not all of that crucial. It's making 3 cuts and you go home. Where a work saw, it's hours on hours and hours, and that piston is going to wear out, and sooner or later it's going to be replaced. On my saws, I prefer a bone stock piston when I'm done porting a saw for a work saw. It's because it's going to wear out, and the customer can simply put a new piston in it and he's right back where he was. If you have a customized piston, pop-up piston, whatever, you can't simply order a piston, throw it in there and go back to work. You be back where you were. A pop-up piston, you definitely can't just throw a new piston in. If you just cut the skirts, yeah, you could just throw a piston in there, it'll run, but your durations will be different, But for a work saw, I prefer to leave the piston stock. I don't want to do modifications on the piston. So I would choose epoxy over, cutting the piston. The other thing is your port timing. And, everybody recommends these. Let's look at the professionals' ideas on port timing. And we got chapters in this book that goes on port timing. And their claims is that to get 7,000 RPM out of an engine, you need 150 to 155 degrees intake duration. To get 12,000 RPMs, you need 195 to 200. This may work in a motorcycle world or a snowmobile world or something like that. But these numbers do not jive whatsoever in the chainsaw world. These books are a great read to get basic ideas. There's some good things in here. Scavenging, that kind of stuff. Here's a transfer port duration chart. Here again, to get 12,000 RPMs, you need 132 to 136 degrees of duration in the transfer timing. I wouldn't ever even dream of raising my transfers to that height. I wouldn't have hardly any blowdown, you know. There was a thing in here well, here's your exhaust duration tables. And this is engine and cc, so I think this is a 2-cylinder, and each cylinder is 62 cc, but I'm not for sure on all of this. But this is exhaust duration, and let's just look at anything here that says 12,000. Look, guys, 200 degrees of duration. You know, we're in my mind, we're barking up the wrong tree here. You know, that's a little excessive. You know, where is that? There's a little spot in here that explains scavenging fairly well, and that's all in your duration timing, you know. Well, I don't see it right now, but I saw it earlier. But keep in mind, these books are not chainsaw oriented whatsoever. And here, this explains, you know, how these engines scavenge. And what I talk about, I want that air to go straight across and hit the back wall, and they're pushing it up and whatever like this, and they're leaving a dead spot here by angling your transfer ports upwards. I want mine to be flat on the roof, so it pushes it and fills this void, and then pushes everything up and over and out. I seem to get better scavenging that way, but it kind of explains how the scavenging works. And you know, but chapter 3, that book, there's a little bit of information in there, but don't get carried away with it. It won't work for your chainsaw. If you go by those numbers, you're gonna have something that probably will turn extreme RPMs but won't have any torque. And we need torque to make this thing work. And you know what sets off a pro porter, a guy that's been doing it for 30 years, got some knowledge, understanding, to a guy that is just a hack, got an idea, saw something on the internet, thinks he can do it himself with a chisel and a hammer and a little Dremel tool, and oh geez, he want to cut the base, he gets his wood router out and sets up a little thing and cuts the base with a router, and on and on and on. I've seen it all, guys. It's the failure rate. Do they get some gains out of their saws? Yeah. I know. I've seen it. I've run them. I know. But the saws don't last. And then we see catastrophic failures. You know, not quite understanding what they're doing. Do I stand behind it? Well, it's in my shop, so this ain't one of mine, you know. I studied his cylinder here a little bit. I took his port timing numbers off from him. I don't know. That doesn't really make a lot of sense to me. But I did measure the port area of his port, and he didn't get crazy with it. It's still less port timing or port area than the carburetor. So, I mean, he got somewhere. He's got about 510 in there, and stock was 462, but he needs to get up there around 572. So, you know, got halfway. Yeah, you also put a external, at one point, external impulse on it. This is the original impulse. It's an external add-on. Drilled a hole through there. That idea is okay, but you needed to put a little notch in here. piston covers it up, right? Needs to have a little notch in here. He didn't do that, which is something I'm going to modify mine as well, but I'm going to leave mine internal. I'm going to drill that hole all the way through into the cylinder, and then I'm going to put a little notch in here, and I'm basically going to have a double impulse there. And the reason I'm doing that is because I'm going without a gasket. I'm going with sealant, and there's a chance I'll plug this hole with sealant, and so I would rather have a second port coming up through there to ensure that I have good impulse when I get it all done. Little things. Again, that's kind of the difference between knowledge and somebody that has a kind of a bright idea. I mean, the idea ain't horrible, it's fine, but I don't know what he was going to run for a carburetor. 3120, you'd have to have a nipple right here for the impulse. It's right now, it's right there. The external impulse, you have to drill this right where that little button is right there. You have to drill that out, put an impulse pipe in there. I think the steel uses the same cover or same basic carburetor, Walboro, and that this top plate has a impulse in it already, and you could just buy that plate or put it in yourself, either one. So what I'm building here is somewhat of a race saw, I guess. I'm not going to get crazy with an RPM saw that turns 15,000 RPM. It may when I get done, but it's usable torque is what I'm after. Sometimes the RPM comes with it, sometimes it don't. I'm sure this is going to turn a lot faster than stock, but not insanely high. Freeload RPM out of the cut does you no good whatsoever. It's the RPM that it holds in the cut that counts, and you have to have torque with that RPM to make it work. So that's what we're chasing after. I already did a little work on this block. I kind of reshaped it a little bit. I got this diameter the way I want it. I put a gasket on there, but when I put it on here, it's I don't know if you can see in there. We got a little metal to remove in there. We got some shoulders in there, some problems in there, and then we'll get this opened up all the way. Seeing this needs a little more ignition timing to it. I'll gain my area by lowering the floor. I got to do a little bit on the width too. It's a little bit odd shaped, so I'll get a little bit on the width and the rest on the floor, and then I will be cutting the skirt to get the timing I desire. And by doing that, I don't have to do any epoxy work in the cylinder at all. I don't know if there's much else I need to really talk about intake stuff here. Well, I could talk some more about exhaust port stuff, but I believe in my mind that the area of the carburetor should be the same as the area of the port. The area of the boot should be the same, or the block, whichever the saw has, and that area should be all the same. It's not restrictive and it's not lazy, if all of that makes sense to you. Main reason why I put a lot of epoxy in 660 cylinders. They have too much duration to begin with. Generally, once I lower the cylinder, they do, to raise the compression. But 660s are notably wildly different on all their port numbers. If you've been at it for a while, you'll know. And it does not matter if it's an old red lever, red light, whatever. It's all the same. If you're lucky enough to get a 660 cylinder with low numbers in it, it's going to perform much better than a 660 with large duration numbers in it. And when you get that one with low numbers, yeah, you got something that works. But it does not matter. Red lever, red light, anything, it doesn't matter, guys. I've gotten relatively new 660s with good numbers, and I've had a lot of old red levers with just horrible numbers. So it doesn't matter. The red lever thing, you know, somebody had one, good numbers in it. They had a lot of these old saws they wanted to sell. They took that one, really good one, ran around all over with it. Like, oh God, these red lever saws are so much better. And he sold all his saws for premium price. And, you know, the folklore continues, right? I don't get into the old stuff. The newer, like the 440s, the slant fin 440, red lever, 10 millimeter. The 440 cylinder has better porting than the slant fins, and the 10 millimeter crank is weaker than the 12 millimeter. That's why they went through all the changes. Pin location is different on the piston for the ring pins. So, you know, you got to pay attention to all of that on slant fin stuff. I don't know, guys. All that old stuff I don't mess with. I mean, to me, it's a whole bunch of folklore. Let's sell what we can, get a big price for it, old junk, and the next guy can deal with the junk however he wants to deal with it. I prefer newer stuff. Even like the 462s, 400s will more than outperform them old saws. They're just so much more into them. Better porting, better port designs, on and on and on, and they're just going to shine. So better fuel economy, on and on and on. And this is one of the big things on fuel economy. You know, we got this great big huge freaking port in this thing, stupid port numbers in it, and that's why a 660 is so hard on fuel. But throw some epoxy in there, they get better on fuel and they perform better. You know, all the way around, I'm getting more out of those saws. And you want to talk about production, work saws and production saws. We can make them just absolutely scream. They're out of gas in 10 minutes. You're not making production if you're, you know, constantly camped out at the gas can. So I take all of that into consideration when I'm building a work saw. We don't want saws that are extremely hard on fuel. We want them to perform. We want them to get something done. So, you know, I'll trade off a little performance for fuel mileage. It's production, guys. It's not, we're not racing. We're, you know, trying to get some wood on the ground. So anyways, till the next one.